Our starter problem today is this. We've got 3 charges and they're all lined up like this. Nice and simple. And so we've got a point charge here, and someone deposited 5 microcoulombs of charge right here. There are 7 microcoulombs of charge here, and negative 4 microcoulombs right here. These are 2 meters apart, and these are 3 meters apart. And what I want to know is, I'm really concerned about what are the forces acting on this second charge right here. So what is the force on Q2 from Q1? And then what is the force on Q2 from Q3? And then what is the total force on Q2? Find the total force on Q2. Oh, I don't need a question mark there. All right, so let's solve it. And this is a basic, let's do part A. This is just a real basic problem applying Coulomb's law. Coulomb's law says this. The force is equal to the electric constant K times the 2 charges. Well, what are the charges? Q1 and Q2. Over the distance between them squares. And what I'm going to do is I'm going to put between, R is the distance between charge 1 and charge 2, and I'm going to square that. So that little 1 and 2 right there is just to say the distance between Q1 and Q2. I'm going to call it R1, 2. And this is going to be in the R hat direction, which means away from. So this is what we talked about last time. So if you were absent last time, make sure you get caught up and watch the lecture for that. So the electric constant is 8.99 times 10 to the 9 Newton meter squared per Coulomb squared. And then Q1 is 5 microcoulombs. And Q2 is 7 microcoulombs. And the distance between them is 2 meters. So I'll go ahead and square that. And now I just need to punch all that into the calculator. Now, again, let's do that. This is 8.99 times 10 to the 9 times, and then watch what I'm going to do here. 5 microcoulombs. 5 times 10 to the negative 6. You have to remember to do that, or your answer is going to be, well, if you don't do it either time, your answer is going to be a trillion times too big. Only off by a factor of a trillion. Okay, times 7 times 10 to the negative 6 divided by, and 2 squared, I'll just do that in my head, it's just divided by 4. And you get 0.0787 newtons. Okay, so that's the answer for part A. Okay. And this is the force of 1 on 2. And that's usually how I will write these things. This is the agent. The first number is the agent, the thing that's applying the force to the object I'm looking at, which is 2. So this is the force of charge 1 on charge 2. Now, one of the things I left off here, what direction is it in? What is this R hat? Now, R hat means away from. So what direction is away from Q1? Well, it's not attracted, it's repelled. So what direction is that? To the right. Or you can say in the X direction. If we set up a little axis system, here's X and here's Y. We don't really need the Y direction in this problem. But to the right or in the positive X direction. So I would make this positive 0.0787 newtons. Now for part B, I would say the force of 3 on 2. And that's going to be K Q3 Q2 over R. And then we want to know the force, or well, R between 2 and 3. It doesn't really matter there, the order that I put that. And that's going to be in the R hat direction. And again, we have 8.99 times 10 to the 9 Newton meter squared per Coulomb squared. And notice Coulomb's time a Coulomb is a Coulomb squared. And we got the meter squared, so you're left with newtons. And what is Q3? Q3 is negative 4 microcoulombs. And this is 7 microcoulombs over R23 squared. Now, here's what I'm going to do. I know I called this a negative charge, but that negativeness is just going to have an effect on the direction of the force. So we're going to take this negative and put it with the negative R hat direction. I'm going to take this negative away from the charge and just put it over here with this R hat. And then we'll kind of figure out what that means. So F3 on 2 is equal to, well, we got to go through all this again. Let's see, 8.99 times 10 to the 9 times 4 times 10 to the negative 6 times 7 times 10 to the negative 6, microcoulombs. And then, oh, I forgot to put the, I should have put the numbers in. This is 3 meters squared. So I can do that in my head. That's divided by 9. And I get this, 0.02, actually 280 newtons when I round it off. Let's see, when I round this off right here to 3 significant figures, I'll get that. Okay, now, what's the direction of F of 3 on 2? Well, it's in the negative R hat direction. Now, what is negative? That means towards. It's attracted. In other words, Q2 is attracted to Q3. Now, look at this. What direction is that? Yeah, that's to the right. So isn't that interesting? If you just blindly followed the sign of the, Q times charge 1, Q1, or the times the 2 charges divided by the distance squared, you get, it's a negative force. And then you might end up subtracting them, right? Adding this plus a negative, you get the wrong answer. So what I like to do is I like to keep the R hat, especially if one of these is negative, put it over here and then place the negative with the direction. And say, negative R hat. Then go ahead and get the magnitude of the force and then carefully inspect, what does negative R hat mean? And when I look at the picture of it, okay, that means I'm attracting that charge here, and so it's also going to be to the right. So part C is it's just the force on here. Well, if I look at this, this is being repelled by this guy by 0.0787 newtons. And this one is being attracted, not quite as much force. It's a little farther away and it's a little smaller. But they're just going to add. So the total force on charge 2 is equal to 0.0787 newtons plus 0.0280 newtons. And so F2 is equal to 716 and that's going to be 10 or 0.1067 newtons, tenth of a newton. Almost. Okay. Oh, to the right. And actually, well, to the right. And actually, since up here I defined my x, as being to the right as being positive, you can just say it's positive force. But here's the reason I came up with this is that if I give you two charges along a line, that you might get a negative force, but you have to, because one of the charges is negative, but you have to carefully inspect what does that negative sign mean. To put the negative with the negative r hat, that means it's attractive, and then you have to decide, well, is attractive in the x direction or the y direction, positive, negative, and then you're prepared to add these together. Any questions? Okay, that is all.